Uh, Good morning, friends. Today we are going to study the transmission system and the gearbox of the wind energy generation system. Okay, so as we have already studied, see this is the block diagram. So there is a need of a transmission system and the gearbox arrangement because the generator that we use, okay, uh, requires very high speed, and that much high speed is not obtained by the wind turbine. Okay, this is, let us say this is a hub and the wind turbine. We already have studied the constructional details of a horizontal axis wind turbine. So consider that these are the blades of a wind turbine. This is a central hub. So it is rotating with the help of a natural wind. Okay, so whatever speed has been received, that is not sufficient to drive the generator. For that purpose, we need to have a gearbox and a transmission system to transmit the speed gained by the wind turbine, or say blades of the system, to the generator. Okay, so acts as a turbine whose input is kinetic energy of the wind, okay, that has been converted into mechanical energy, rotational energy. So it is given through bearing to the gearbox. So gearbox, generally for wind generation, it is one gear ratio or two gear ratio system has been used. Okay, so there are gears, okay, and then it is coupled to the generator. Okay, this is permanent magnet synchronous generator which is used for generation of the electricity in case of a wind turbine. So turbine is attached to this generator, and whatever is the generated energy that we can utilize. So generation is AC because AC generator is there. Directly output we will get AC. Okay. So let us see what we have studied. Speed of the electrical generator is much higher than the speed of a wind turbine. Okay, and that's why we need to change the ratio of the gear, and accordingly we can adjust the speed required to the generator even though we have less speed. Therefore, gearbox is inserted in the transmission system. As wind speed varies from low to high, the gear ratio is also not fixed and needs to be varied to get the maximum efficiency. So why we all are doing it? Because generally depending upon the geographical location, we acquire the wind speed. If the wind speed is less but more than, let us say, 5 meter per second, then surely we can generate the energy from the wind. We can extract the energy from the wind, and depending upon the gear ratio, we can increase the speed. So by increasing the speed, we can run the PMSG, permanent magnet synchronous generator, so that we can use the electrical energy at the output, and accordingly we can utilize it. Okay. For a constant speed wind turbine, fixed gear ratio is set. Suppose we want a constant speed, we can have a fixed gear ratio, so that constant speed we will get, and we will get the rated power output. Okay. Whereas for variable speed wind turbine, a better overall efficiency may be obtained with the two speed. So generally, one speed or a two speed, depending upon the rating available and whatever is the availability of the wind speed, depending upon that, we can have one or two gear ratios, not more than that. Okay, this is standard. It switches from low gear ratio to high gear ratio at low wind speed. So depending upon the wind speed, suppose wind speed is between 5 to say 7 meter per second or 7 to 15 meter per second. Depending upon that, we can adjust the two gear system. Okay, so this is what about the transmission system and gearbox needed. Okay, so thank you for today.